Hello all and welcome to the Math 8 video on one-step equations. Today we're going to talk about just some equation basics, obviously how to solve one-step equations, because this is an important step, no pun intended, into algebra, meaning once we start with one-step equations and we figure out how to do those, we can actually expand on this, and that's how we know how to do two-step equations, multi-step equations, equations with variables on both sides, and so on and so forth. So the basics to solve an equation will be discussed here, and like I said, we'll build on this as we go in order to solve more and more complex equations. Okay, so big thing here is, let's look at the steps to solve. It's kind of misleading here. It says one-step equations, but you see 4 steps to solve here, okay? But the one step is, as we'll see in some of the examples, is referring to how many operations we have to do in order to solve the equation, okay? Now, in this case, the steps to solve, I'm not too worried about everybody remembering word for word what these steps are. It's just these are the things we're going to kind of check off as we go down the list here when we solve each equation, and eventually you'll get to the point where you just do this automatically. You don't have to remember the steps for every single equation. It's just once you figure it out and get good with solving equations, it kind of comes naturally, and all these things kind of just happen as you solve the equations. Okay, so first thing we need to look at here is the first step is locate the variable. Okay, each equation is going to have at least one variable. In this case, all the equations we're going to do this year have only one variable. Okay, so we need to locate what it is, and that could be x. All right, the general one we always tend to use in math is x, but there could also be m's or z's or a's. Okay, or d's, or whatever variable you can think of. It could be smiley faces if you really wanted to use smiley faces as variables. All we're doing with these is they are taking the place of a number. So this variable is going to tell us, okay, what it is we're even looking for. Okay, we're looking for what this variable represents. What number is this variable? Okay. The second step is determine the operation tied to the variable. Now, with these equations, we're going to do things very basically here. So we're only going to be worried with the 4 basic operations here. So those operations are addition, subtraction, multiplication, and division. Okay, we're not going to worry about a few of the other different types of equations you could see, such as maybe having to deal with square roots, or having to deal with absolute values, or anything crazy like that. All we're worried about are the 4 basic operations that we're used to. So addition, subtraction, multiplication, and division. Now, each one of those operations has what we call an inverse operation. So what we're going to do, and we'll discuss that here in just a second, but what we're going to do is we're going to use these things we call inverse operations on both sides of the equal sign. So notice here that I underline inverse operations because that's the main thing about this step. But the other big thing that we have to realize is we have to do the inverse operation on both sides of the equal sign. Okay, so once again, if you need to or you'd like to, highlight, circle, underline, box, whatever you got to do. This is the biggest part that most people struggle with, is we got to do it to both sides of the equal sign. Okay, and then the last thing is simply check your solution. Okay, and I'll be quite honest with you, there's no reason anybody should ever get an equation wrong. If you get a solution to an equation, you can check your solution to make sure it is correct. Okay, so with that being said, I'll show you how to do that with a few of the examples here as we go forward. But all you really got to do is take your answer and plug it back in and make sure that it gives you something that's true. Okay, So those are the 4 steps, but instead of sitting here boring you with talking more words and definitions and all that, well, we do have one more thing to cover before we get into the examples, which are inverse operations. Okay. So we mentioned inverse operations in step 3, and the inverse operations are used to solve equations, meaning, okay, we have an operation we're doing to a variable. So let's say we're doing addition to the variable. Let's say we're adding something to the variable. Well, the inverse operation that we're going to use, well, in this case, inverse is a word that means opposite. So the opposite of adding is subtracting, okay? And then you notice it's a double-headed arrow here, meaning, all right, addition is the inverse operation of subtraction, and subtraction is the inverse operation of addition. So it kind of goes back and forth. If you have addition, then you need to do the opposite, which is subtraction. If you have subtraction, you need to do the opposite, which is addition. And the same thing happens with multiplication and division. So if you have multiplication of a variable, well, how do you get rid of the multiplication of a variable, or how do you undo that, or how do you do the opposite? Well, that would be with division. Okay, and then vice versa. If you have division, the way that you undo that, or the inverse of division, is multiplication. And you'll see what I mean by that when we look at some of these examples. But this is the big thing that governs basically how we do any equation. Okay, you got to know what the opposite operations are, the inverse operations are for each of these operations. Meaning, okay, if I know I'm doing addition, I need to know that the opposite of addition is subtraction. If I have subtraction, I need to know the opposite of that is addition. And you'll see why here when we look at the first example. And that's where we'll go right now. So set 1 here. So set 1, these are all equations dealing with addition and subtraction. Okay, so all you're going to have to worry about here is either adding or subtracting numbers. So let's follow the rules here. Okay, so the first one was, let's identify the variable. Well, if we look at this equation, we have x plus 7 is equal to -1. So in this case, everybody can hopefully see that the variable we have is x. Okay, so that's the first step. Locate the variable. Well, right there it is. Okay, and that's the only variable we have, x. There's no y's, p's, q's, m's, h's, w's. There's nothing here but an x, one x. Okay, but then the second step tells us to determine the operation tied to the variable. Meaning, what are we doing to the variable? What operation are we doing to the variable? Well, we have x plus 7. So that means we're adding 7. So in this case, our operation is addition. Okay, so then that means we determine the operation. The operation is addition. Step 3 tells us to use the inverse operation on both sides of the equal sign to solve it. Okay, so what is the inverse operation here? Well, once again, if our operation is addition, the inverse of addition is subtraction. So that means we're going to subtract, well, it's got to be exactly the same. So meaning if we add 7, well, the inverse of that would be subtracting 7. Okay, so notice how I write this. I'm writing subtracting 7 right underneath the 7 because I'm going to add 7, then subtract 7. But then, and this is where we need to follow the second part there, the most important part in my opinion is both sides, meaning, okay, here's the equal sign. The left side here has the x plus 7. The right side is the -1. So since we subtract 7 from the left-hand side, we need to also subtract 7 from the right-hand side. And the whole goal in this is, and you can kind of guess maybe where this is going, is x plus 7. So if we add 7 and then we subtract 7, it's just like we didn't add anything at all. We added 0 pretty much because that's what ends up happening here. If we do 7 minus 7, that's 0. X plus 0 is just x. And that's the whole goal with solving equations is we want to get the variable on one side by itself. And as you'll see as we go along, usually I like to have my variable on the left-hand side. But you could have the variable on either side, but as long as it's by itself, this will now tell you what the answer is because all we got to do now is do -1 minus 7. So if we do -1 minus 7, that gives me -8. And that's actually the answer. That's actually it. That's all we got to do. The one step that it's referring to here, so for one-step equations, is we had to subtract 7. So if our operation on the variable is addition, we do the opposite in subtracting. Okay. Now the part about checking your work, I'm not making you actually write out the check every single time. Okay. But good practice is you have -8 here. Well, if x is -8, plug it back into your equation, meaning plug in here. So like we've done before in terms of variable substitution, take -8, plug it in for x. -8 plus 7, well, that's equal to -1. So that means our answer is correct. And you could do that very quickly on a calculator if you needed to. Just literally plug in -8 plus 7 and make sure it gives you something true over here. Make sure it gives you what this is supposed to be equal to. -8 plus 7 is -1. Okay. We see the same thing happen with number 2. Except in this case, we identify the variable. It's just m. Okay. So we have m minus 11 is equal to -9. Once again, the variable's m. Operation here is subtraction, so m minus 11. So that means, what's the opposite of subtracting 11? Well, that's adding 11. Okay, once again, we got to do it to both sides. So if we do it to the left side, we have to do it to the right. Meaning, if we do m minus 11 plus 11, those are going to go away, giving us m. Once again, minusing 11 plus 11. So if we have basically -11 plus 11, that's going to be 0. So we have m minus or m plus 0, which is just m. Okay. And then over here, the only calculation we really have to do is -9 plus 11, which if you have a calculator especially, that should be super easy. M is equal to 2. Okay. And once again, check yourself by taking the 2, m minus 11, so 2 minus 11. If you do that calculation, that should give you -9. Okay. And that's all it means by checking your solution. Plug it back in. And once again, if you do that and you see that that's the right answer, then you know you've got that question right. All right. You don't have to worry, well, did I get this equation right or wrong? Okay. You can actually check your work with any equation that you solve. Okay. Now, number 3, we get into something a little bit tricky here. Some of you might recognize, okay, so the variable here is h. So we have 9 is equal to 14 plus h. Well, some of you see the variable is actually on the right-hand side, which is perfectly fine. You could actually solve this just as well as the variable on the right-hand side as it is on the left-hand side. But just to be consistent here, I always like to have my variable on the left-hand side. So look at what I've done here. All I did was I took, okay, if 9 is equal to, so something on the left is equal to something on the right, it actually doesn't matter which side of the equal sign they're on, they're still going to be equal. So all I did was I flipped across the equal sign, meaning I took this 14 plus h and moved it to the left, and I took this 9 and moved it to the right. So now I have my variable on the left-hand side. Now you don't have to do this, okay? I'm just showing you how I like to do it in terms of getting my variable on the left-hand side, and so that it works the same as the last 2 equations that we just did, okay? The other thing that you can notice is, well, there's 14 plus h, so the constant term is before the variable term. So in this case, since there's addition here, okay, so if you watch some of maybe my other videos, you might have noticed I talk a lot about writing things as sums. Well, this is particularly why, because if we know this is addition, this is a sum, well, I can write it like this. Meaning I can flip across addition too, because 14 plus h, let's say h is 10. Well, 14 plus 10, that's 24. What's the same thing as if I did 10 plus 14, which is also 24. So no matter what order that I add 2 numbers, it's going to end up being the same. And now when we look at this, this looks a lot like number 1, whereas I've got the variable h plus 14 is equal to 9. So my operation here is addition. So what's the opposite of adding 14? Well, subtracting 14. But then you got to do it to both sides. And if you still need to, draw the little line there so you can keep track of, which side is which. h plus 14. So if you add 14 then subtract 14, those will essentially go away, leaving you with h. And then 9 minus 14, once again, some basic arithmetic here. You do get a negative number in this case, though. 9 minus 14 is negative 5. Okay. So on that one, a little bit of something different in that you maybe had to switch some things around. But I did want to point out that if you saw it from the beginning, some people might have saw this and saw 14 plus h and just saw to, well, how am I going to get the 14 away? The positive 14? Well, I'd have to subtract 14. Okay. So you can skip these steps right here if you wanted to. You don't have to move things around and move the terms around, although in some of the later examples we're going to do, especially when we get into more complex equations, it does benefit you in order to, in being able to switch things around. So in order to flip things across equal signs, or in order to flip things across addition like that, okay? Because we're going to see the same thing with number 4. Easy way out here is to say, okay, well, I've got negative 15 plus w is equal to 14. Once again, my goal is to get this w, which is the variable, by itself. Well, we're adding negative 15 to it, but here's where it gets a little tricky. How do I get rid of a negative 15? Okay, well, some of you right from the start could probably say, well, if I wanted to get rid of this negative 15, I would add 15. Okay, and just from the start, you could do that. But I'm going to take it one extra step further and say, well, my variable's already on the left, but I have addition here. So I can actually flip this around and write this as w plus negative 15 is equal to 14. And then the other thing, which is something we've seen before too, is we have w plus negative 15. Well, I can simply just rewrite that as w minus 15. And now I've got an equation that works just like number 2, all because I switched some things around here. So I took this addition, flipped the terms around, and saw that I had addition of a negative. Now here, once again, you could have went from here and said, all right, I'm adding negative 15. So what's the opposite of adding negative 15? Well, subtracting negative 15. But in that case, once again, you're dealing with negatives and it gets a little nasty. So instead of having a negative here, we can just say if I have plus a negative, that's the same thing as minus a positive 15. So now I can clearly see, well, what do I have to do? I have w minus 15. The opposite of subtracting 15 is adding 15. Once again, I'm going to make this curvy. Usually you can do it in a straight line, but I'm kind of pressed for space here. But that's the thing. Draw the sides on each. Once again, I got to add 15 to each side, meaning the minus 15 plus 15. Essentially, those cancel each other out, leaving me with w. And that's equal to 14 plus 15. Easy arithmetic here. W is equal to 29. Okay, and that's pretty much it. Now we're going to look at a couple more examples here, but they both work very similarly to the last two that we just did. Number 5, negative 21 is equal to k minus 8. Well, once again, from here I can see the variable's k. I'm subtracting 8. I would need to add 8 to both sides. And once again, you can do that with the variable being on the right. That's no problem. I just like having my variable on the left. It's just a preference thing here. And for some people, it might be the difference between being able to solve an equation and not. Because if you can get it in the same form, now if we wrote it this way, number 5 works exactly the same way as number 2. And number 4, once we got down to this point. Okay. So once again, k is the variable. We're subtracting 8. The opposite of that is adding 8. And same thing. If we add 8 to the left, we got to add 8 to the right. So the whole point here is those will go away. So we have k is equal to another one that you might need to, if you have trouble with negatives and stuff, negative 21 plus 8, I'll go ahead and tell you that's negative 13. And just like before, and I like the other ones as well, plug this back in if you're unsure. Take negative 13. So negative 13 minus 8, if you do that calculation, that should equal negative 21, and it does. Okay, so that tells us negative 13 is correct. And you could do the same with all the rest of these. Negative 5. 14 plus negative 5, well, that's 9. That's good. 29. Negative 15 plus 29, once again, Negatives, I understand people have some trouble, so if you need to, plug that in your calculator. Negative 15 plus 29 is 14. Okay. And then the last one here, which is the toughest one, but it's the same kind of thing that we had with number 4, in that we've got a constant term plus a variable term. And in this case, it's actually a little bit different, even more so, because our variable's on the right. But like I said, we can just take a couple extra steps here. So all I did was flip across the equal sign, and now I can flip this around and make it like that. And last step, to make it 100% doable like we've done before, write this plus -4 as -4. So once again, v minus 4, that tells us our operation is subtraction. That means we need to add 4. And like I said, you could have done this up here just by saying, okay, we need v by itself. Well, how do I get rid of this -4? Well, I would add 4, okay? But the whole point here is those go away, same kind of thing. Looks like a little nose there or something. But anyways, that gives us v is equal to -1 plus 4, 3. And the same kind of thing, we just plug this in. -4 plus 3, well, that does in fact equal -1, so our answer is correct. And that's pretty much it in terms of solving a one-step equation with addition and subtraction. The tricky part here is, okay, so if maybe you wanted to write a little note or something, move terms around if you are unsure what operation to use. Okay, meaning doing what we just did over here. So flipping the terms around, meaning, okay, flipping across the equal sign, and then also flipping across addition here. Because once again, it doesn't matter what way things are added together, they're always going to be the same. So -4 plus v is the same as v plus -4. And then in this case, I go the extra step and saying, okay, if I have plus a negative, I can just rewrite that as -4. But now we get into ones that I consider maybe a little easier, okay, and it's set 2, which has to do with multiplication and division. Now, once again, in these, you need to know, okay, well, if I have multiplication, the opposite of multiplication is division, and vice versa. If I have division, the opposite of division is multiplication, okay? So, with that being said, let's jump into number 7. Same steps apply, though, okay? So number 7, we have 4a is equal to -24. We do need to remember that if we write something like this as 4a, that means 4 times a, so this is multiplication. So in this case, we need to do the opposite. So if we're multiplying a times 4, the opposite of that is dividing by 4. Now do notice the way that I'm signifying that I'm dividing. I'm using a fraction bar, okay? And that's going to be common practice, as you see here in number 9 and number 10. Common practice going forward is that when you see division, most of the time anymore in algebra, geometry, and going on forward in math, usually you always see it as the fraction bar, okay? But the same thing holds is if you divide by 4 on the left, guess what you have to do on the right? You also have to divide by 4. So that's where the little line comes through and say, if you do something to this side of the equation, you got to do it to this side, okay? But the whole point here is if we multiply times 4, then divide by 4, the same kind of thing happens. We get the 4's cancel out. A little too far there. We get the 4's cancel out. But in this case, they cancel out in a little bit different of a way. If we do 4 divided by 4, that gives us 1a. So they cancel out in that they give us a coefficient of 1 here, meaning we just have a. And then the one-step equation here is literally just, all right, -24 divided by 4, negative over a positive is a negative. 24 divided by 4 is 6. So the answer is -6. Now, Just like any other equation, you can plug that back in and solve, meaning take -6 and plug it back in. 4 times -6 is -24. So that means our answer is correct. Number 8 is exactly the same except for the variables on the right. So we can take the extra step if we wanted to and rewrite it like this, which doesn't change the process at all, just makes one extra step. That way we have the variable on the left-hand side. But the step is still going to be the same, meaning, all right, what am I doing to the variable? Well, the variable here is p. I'm multiplying it times -7, so that means I need to divide by -7. But if I do it to one side, I need to do it to the other. So what we have here is the -7's go away, leaving us with p. Once again, -7 divided by -7 is 1p is equal to, your times tables, this should be fairly simple, but I know 56 divided by 7, I know this on the times tables, it tends to give people some trouble. So once again, if you have any problems with this, double check yourself on a calculator. I have no problem with that. But we have -56 divided by -7, so that's negative over a negative was a positive. 56 divided by 7 is positive 8. And then once again, check your work by just plugging it back in. So -7 times 8 is -56. So that means our answer is correct. Now, number 9, we start off with our first one with division, okay? But it works exactly the same. You find the variable. The variable's right here, n, and we're dividing it by 5. And that right there is equal to 9. So in this case, we have n divided by 5. Well, if we're dividing n by 5, what's the opposite of dividing by 5? Well, that's multiplying times 5. But I do want people to be careful with this, okay, because in a way, a lot of people write the multiplication here. They might write it down here, and they think they need to multiply 5 times 5. Well, if it helps you in dealing with division like this, and notice there's the fraction bar, technically what we would be doing is multiplying times 5 over 1. So we would have 5 times n, or 5n, over 5, which is the same kind of thing we had up here. 4a divided by 4, well, the 4's just cancel out. 5n divided by 5, well, the 5's are just going to cancel out, leaving us with n. And once again, we got to do it to both sides, meaning we multiply one side times 5, we got to do it to the other. So 9 times 5 gives me 45, and that's it. And we check that by plugging it back in. 45 divided by 5 is 9. Okay, by plugging it into the original equation. So 45 checks out. Number 10, same kind of thing here. 2 is equal to r divided by -8. Once again, we can do one little thing here to just normalize it, make it, the same as what we just did over here with number 9. R divided by -8 means we need to multiply times -8. But like I said, think of it as -8 over 1, because once again, the whole goal here is we want these -8's to go away, leaving us with r. But at the same time, we multiply this side times -8, we need to multiply 2 times -8. So 2 times -8 is equal to -16. And once again, just plug this in. -16 divided by -8. Negative over a negative is a positive. 16 over 8 is 2. Okay. So once again, matter of just plugging back in. That checks our solution. So we know we've got the answer correct. The last two here for numbers 11 for the multiplication. Now number 11, this is kind of a little special of a case. So we have -k is equal to 7. Okay. Well, in this case, there's no number in front of the k. There's no number under the k. In this case, you see it's in the section labeled multiplication and division. Well, just like we've done before when we're simplifying expressions, if a variable doesn't have a number in front of it, we can always add a 1. So what we can think of this is as we can think of this as negative 1k equals 7. So in this case, that means I'm multiplying k times negative 1, meaning I need to divide by negative 1. Once again, the whole point here is to get rid of these negative 1s, so we just have a 1k, okay? And then just the one step that we have to do here, the one operation or the one calculation we have to do is 7 divided by negative 1. Positive over a negative is negative. 7 over 1 is just 7. Okay, so in this case, k is equal to negative 7. And just plug that back in. Well, in this case, it's a little bit different because, all right, I'm going to plug in negative 7 in for k, so negative 7. Well, you can think of it as saying, what's the opposite of negative 7? And that would be the positive 7. But once again, you can always think of it as a negative 1 in front of the k if it just says negative k. Okay, so divide by negative 1 gives you negative 7. And the last one here, x divided by negative 6. Well, we're dividing x by 6. So that means we need to multiply both sides by negative 6. Okay, but if we do it to that side, we need to do it to the other side here. Notice I'm using parentheses over here to make it to where there's negatives, don't make it confusing. But in this case, we have negative 6, okay? The negative 6 is the whole point. We want those to go away. So we have x is equal to, okay, well, negative 12 times negative 6 is positive. Okay, positive 6 times 12 is a positive 72. And once again, to check yourself with that, if you need to, double check that in the calculator. But that's another one that should be from your times tables, 12 times 6, 72. But in this case, to check it, do 72 divided by negative 6 and make sure that gives you negative 12. And there you go. And that's all there is to one-step in equations in addition and subtraction, multiplication and division. So what I'm going to ask you to do now is just to get you some practice. Set 3 is a mixed practice. Okay. So what I suggest doing if you're watching this video is pause the video. Okay. Go through, try your hand at the next 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 questions. So there's 12 different equations here for you to practice with. Practice with those. See if you can't do these on your own, and then restart the video here in just, after you get done, and go through and make sure that you did all these correctly and you got the right answers, okay? So I'm going to go work through all of these. I am going to go through these a little bit quicker because, once again, double check, but just make sure you get the same answer that I do, okay? And that you're doing the same operation. So meaning if I add 11 to both sides, make sure you're adding 11 to both sides. If I divide both sides by negative 10, make sure you're dividing both sides by negative 10. Because it's the steps that matter. It's not so much the numbers that you get, okay? It's the steps, though. So the same way we work number 13 here, I'll go ahead and give you a hint. The way you work number 13 is the same way we did number 2. Same way we essentially did number 4. The same way we did number 5. Okay. So try your hand at these, and like I said, pause the video and come back here in just a moment whenever you get all these done and check your work. So give everybody a chance to pause and do that. But so let's go over that now. Okay. So number 13, x minus 11 equals negative 3. Well, the operation here, the variable's x minus 11. So we're subtracting 11. That means we need to add 11 once again, to both sides. So the whole point here is those go away. We have x is equal to, in this case, negative 3 plus 11. I know negatives trip people up. A lot of people would say this is negative 14 or this is just 14. Once again, you got to look at what's in front of it. Negative 3 plus 11, that is a positive 8. And once again, it says check all solutions. So in this case, we have the solution is 8. Well, plug it back in. Just do a quick check on the calculator. 8 minus 11, that is negative 3. So that works out. Number 14, one with multiplication here, because we have negative 10 times d. That means we need to divide by negative 10. So we divide both sides by negative 10. So the whole point is we want those to go away. We're doing both sides again. So if you need to draw this line, so we get d is equal to 40 divided by negative 10. Positive over a negative is a negative. 40 divided by 10 is 4. So in this case, our answer is d is equal to negative 4, meaning if we plug negative 4 back in, negative 10 times negative 4 is negative times a negative is positive 40. Okay. Number 15, one of the easiest ones so far, a plus 15. Well, we have a plus 15. That just means we need to subtract 15. But once again, what sides do we need to subtract 15 on? Well, the left side over here, and on the other side of the equal sign, we have to subtract 15 from the 2. So once again, the whole point is we want those 15s on the left to go away, leaving us with a, and that's going to be 2 minus 15, negative 13. Okay. And once again, we can always check our answer by saying, okay, well, negative 13 plus 15, that should be equal to 2. And if you double check that, you can find that that is correct. That is true. Number 16, same kind of thing as number. So I'll go ahead and tell you the way you're going to do number 16 is the same way we did number 6, or the same way we kind of did number 4, in that you've got 24 is equal to negative 3 plus h. Some of you might go ahead and be able to see, well, all we got to do is add 3 to both sides. So let me do it that way this time so you can see it done this way. Once again, the whole point is I just want to get rid of this h, or I want to get rid of what's being added to the h. So in this case, how do I get rid of a negative 3? Well, I would add 3. And once again, I'm kind of doing a little bit different than I normally do because I've left the variable on the right-hand side too. But the whole point here is these will go away, leaving me with h, and that's going to be equal to 24 plus 3 is 27. Okay, so that's a good example of you don't have to move things around if you don't want to. Okay, although if it does make it easier for you to solve the equation, just to show you, you could have came out over here and said, okay, this is going to be negative 3 plus h is equal to 24. H plus negative 3 is equal to 24, which in turn just makes it h minus 3 is equal to 24. So then that tells us that's where we need to add 3, so we get h is equal to 27. Like I said, either way, you end up with the same. Now, in this one, obviously, it's a little bit easier in that, all right, we just had to do one step. We didn't have to do all this moving of terms around and all that. So like I said, if you see it this way and you just want to go ahead and say, okay, let me add 3 to get the answer, that's perfectly fine, okay? There's no one set way. Like, you don't have to move the variable to the right or to the left all the time. You don't have to move the terms around to get the variable term first every time. Like I said, if you can clearly see what the operation is that you need to do, you can go ahead and do that operation. Okay, you don't have to, finagle around with the terms and move the terms around and, swap sides and all that kind of stuff. But I just want to let you know it is a possibility. And then once again, you can double check. Just plug in 27 into your original expression. Negative 3 plus 27, well, that is 24. So our answers of 27 are correct. Number 17, picking it up a little bit here, we got m divided by negative 3. Once again, if you need to, you don't have to. So let me just show you this. You don't have to. We're dividing m by negative 3. That just means you need to multiply times negative 3. Technically by negative 3 over 1, okay, on the right-hand side, because once again, the whole point, we want those to go away. So we have m. But if we multiply times negative 3 on the right-hand side this time, we need to multiply it times I'm going to put parentheses around the 4. It's another reason I like having it on the right, because it makes it a little bit easier to read when you got negative numbers. But in this case, negative 3 times negative 4 gives me a positive 12. And once again, just plug it back in. 12 divided by negative 3, positive over a negative is a negative. 12 divided by 3 is 4. So our answer works out. Like I said, you could go over to the side and write it like this, and then do the same exact steps. So the whole point there, those go away. M is equal to negative 3 times negative 4 is 12. Okay. So like I said, whatever way makes it more comfortable for you. But notice it's the same operation, the same step to solve the equation, which is multiply times negative 3. Number 18, this one I am going to move around. So I have negative y is equal to 9. So I just flipped across the equal sign. Once again, just like number 11, you can write this as negative 1y. So that tells us we need to divide by negative 1. So then y is equal to negative 9. And in this case, I'm just going to not draw the line. So I just want to point out, you don't have to draw the line to indicate the sides if you don't want to. If you can clearly see what the sides are, to me, the line just adds a little extra business going on here. It makes it a little harder to maybe see what you're doing half the time. So normally I don't like to draw the line, but I'm also a math teacher that's been doing math for, ever since he was in, kindergarten. He first started learning math, but I went to college for it. And so I've gotten really good at knowing what I mean by sides of equal sign. So in this case, if you definitely need to, draw the line so you know. Number 19, negative 47 plus w is equal to negative 10. Once again, you don't have to move the terms around, so you could just see negative 47. Well, I want to get rid of that because I've got a w over here, a positive 1w. So that means all I got to do is add 47 to each side. So once again, the whole point here is we want those 47s to go away. Negative 47 plus 47, those go away. So I'm left with w. Negative 10 plus 47 gives me 37. And once again, you can do with or without the line, whatever you feel comfortable with, whatever you feel the most need to do. Okay. Number 20, p divided by 9 is equal to negative 9. Well, I'm dividing by 9, so that means I need to multiply times 9. So multiply both sides by 9. The whole point here is to go get that away. So p, 1p is equal to negative times a positive is a negative. 9 times 9 is 81. P is equal to negative 81. And then once again, plug it back in, which I have been slacking off on that. Negative 9, negative of negative 9, or negative 1 times negative 9 is positive 9. So that one works out. 37, negative 47 plus 37. Well, once again, if you do that, you should get negative 10, which we do. Okay, negative 81 divided by 9 gives me negative 9. So that one works out. And then the last four. Okay, now number 24, do pay attention to that one because that one's a special case I really want everybody to pay attention to. So I'm actually going to put stars around that one to make sure people see it and pay attention to it. But number 21, same kind of deal. We see the variables a, we're multiplying it times negative 16, divide by negative 16. Negative over a negative is positive. 48 divided by 16. That one's a tricky one, but that one is 3. So a is equal to 3, or 3 is equal to a. Okay. Once again, if you'd like to flip it around, okay, or draw the line, it's whatever you need to do, okay. But once again, same steps over and over and over again. K minus 9, well, that means we need to add 9 to negative 38. So the whole point here, those go away. K is equal to negative 38 plus 9. It's going to actually be negative 29. That one's another tricky one. It's hard to think about adding and subtracting 9s, but in that case, once again, if you need to use a calculator, negative 38 plus 9 is negative 29. And then the last two here. So this one, v divided by negative 4, that means we need to multiply times negative 4. Multiply times negative 4. Negative times a negative is a positive. 4 times 20 is 80. The whole point here is those go away, so v is equal to 80, or 80 is equal to v. And like I said, if you need to, flip that around, get the variable on the left-hand side, which, like I said, I'm just taking shortcuts just to show you it can be done without flipping it around. Normally, I like to flip it around anyways and have all my answers be like v is equal to 80, a is equal to 3, k is equal to negative 29. So that way my variable is always on the left. Okay, But like I said, I'm just showing you that it doesn't have to be that way. And number 24. This is one that a lot of people end up getting wrong because they'll take this, all right, they say n times 6. So we need to divide by 6. Simple enough, but look what we have over here. We have 0. 6 times n is equal to 0. So if we divide this side by 6, have a lot of people say, well, okay, those go away, so that's n. 0 divided by 6, for whatever reason, I have a lot of people say that that is 6. Or they mix it up and they try to do 6 divided by 0, and the calculator goes haywire and gives you an error. Okay? Be careful and pay attention. This is 0 divided by 6, and you can double check this if you like on the calculator. If you do 0 divided by 6, that is actually nothing more than just 0. Okay? And once again, the whole point here is getting the variable by itself on one side, and then whatever you calculate over here, that is the answer. If I could get a good 0 drawn here. There we go. But once again, check all these. Negative 16 times 3 is negative 48. That's good. Negative 29 minus 9, well, that's negative 38. That's good. 80 divided by negative 4 is negative 20. That's good. 6 times 0 is 0. That's good. Okay? But just be careful and be aware of this idea that you can divide 0 by a number. 0 divided by 6 is 0. Now, if you did that backwards, once again, a lot of people try to mix it up and they do 6 divided by 0. That's not what this is saying. You do 0 divided by 6 in that order, which is just 0. But with that being said, go ahead and attempt the homework. All the homework questions work very similar to all these practice questions. So if you get stuck on a homework question, come back and look and see how we did a similar practice question. And that should give you a hint as to what you need to do. Because once again, the steps are all the same, just the numbers change sometimes, okay? So, but every single multiplication question, so number 24 works the same as number 21. Which works the same as number 18, which works the same as number 14, okay? And I could keep going on and say, okay, well, number 22 works the same as essentially number 19 in a way, okay? Works the same as number 16 in a way, works the same as number 13. So just pay attention to the question, move some terms around if you need to, but always remember, you always want to do the opposite of what it is you're doing to the variable. So always look at the variable and tell whether you're multiplying it by something, subtracting something, adding something, or dividing by something. Okay, and then that should tell you what the opposite is what you need to do. Okay, so once again, if you have addition, the opposite's subtraction. If you have subtraction, the opposite's addition. If you have multiplication, the opposite's division. If you have division, the opposite is multiplication. Okay, so with that being said, like I said, good luck on your homework. And if you have any questions, just let me know. And once again, thank you for watching.